Okay, we're going to get started. For those in the room, please scan in. It's important for tracking the size of the room, and that shows you are here. It also is the way that we will manage the queue, so please scan in. I am Lou Berger. My co-chair Janos Farkas is here with me. Our secretary Eve Schuler is online. So welcome all who are here in the room and remotely. This is an IETF meeting. We're on day 2, so you've probably seen this already. This is our note well. It reminds us of our rules related to participation. And if you're not familiar with it, please go check out the IETF website and the note well. Basically, anything you say and contribute here becomes part of our permanent record and is considered a formal contribution to the IETF. We also have rules, guidelines for how we conduct ourselves in our meetings. We ask that everyone keep the discussion professional. We understand that sometimes technical arguments can get a little heated. It's good to have passionate discussions, but please keep it at the professional level. Do not direct it at anyone personally. If you do feel that someone has acted inappropriately to you, there is an ombudsman team who is available to you to discuss that. For those that are remote, you're here. So thank you for coming. I don't think you need these guidelines. For those in the room, the big point is scan in. We will use that for managing our queue and for our discussion to keep things equitable between those who are in the room and those who are remote. Meet echo piece, I think we're okay on. Note-taking is a really important thing. We do this joint note-taking. We ask that everyone join and help capture a little bit of the discussion. You don't have to capture their presentation. That's in the slides, that's in the YouTube. But the discussion, the gist of the comments, the technical comments, and as well as the decisions, please help us capture that in the notepad. In chat, you'll find a link. On Meet Echo, you'll find a link. There's lots of ways to get there. Please help contribute, particularly if you're making comments at the mic. All slides, all material is online and available. We have 2 sessions. Thank you for making it to the first one. That we will cover the majority of the working group documents and the majority of our agenda. If we are running a little late today on topics, we may spill over the last presentation. We may move from this slot to the next if needed. We're going to try to keep to our agenda, but we do have some room in the second session. So if we have good discussion that goes a little longer, we'll let that conversation happen here. The second session is on Thursday. We hope you can make it there as well. The agenda is posted. We have, I don't believe we had any changes from the draft agenda that originally went up. There was one request that we had missed, but that person had said that they were okay not presenting, and so we'll hear from them in the future. Please focus on changes and plans for completing the document. If you have open issues you would like feedback from the working group, now is a great time to bring them up. Of course, we use the list to confirm any discussion that happens here and confirm working group consensus. So we're pretty excited. We have 3 new RFCs. You know, it's great to come here and talk, but in the end, the reason we're here is to publish documents. So we have 3 that have come out since the last meeting. Thank you all who've contributed to those and the working group for helping progress this work. That's really wonderful to see. Similarly, we have 2 documents in the RFC editor queue. That means our work is largely done on these as well. And now we just wait for the final publication process. We have one document that is with the AD. There were some comments made on that, and on the list recently, we look for the conversation to continue there to resolve the issues. We have one document that's post last call, raw architecture. We're getting closer. We're getting really close. We think, well, we'll hear more about it. It's on the agenda. And one relatively recent adoption on taxonomy that is going to hopefully help us categorize the different queuing solutions that are being discussed. And so that's a really important document. It too is on the agenda. We have a few documents not on the agenda. The control plane framework, we think, is pretty close to last call. I think we were going to do it one final read and then do a last call on that. The scaling requirements is pretty much parked for the moment until we get a little more work on the solutions. But we don't see a lot of change happening there, but the document's still open in case we discover that the requirements aren't quite right and quite aligning with our solutions. I don't want to, do you have anything you want to say on industrial?
There is some discussion going on the list.
Yeah. And you'll hear more about the raw framework as part of the raw architecture. Basically, they're going to say that they're going to revive that as soon as the architecture is complete. We have a couple of incoming liaisons. The first one went to multiple working groups. Please take a look. If you think that you would like to have a response, please propose it on the list. We'll probably bring it in, bring in the other working groups if we decide that we want to respond. At this point, we don't see a specific response on the horizon for that one. But again, we're always open to contributions. The second liaison is a little more interesting. That was sent to us. And there's been some discussion about that we're probably going to want to do a response on this one. And if we do move forward with the response, as usual, we'll discuss it on the list.
Yeah, just to let you know that it was addressed to us, IEEE 802.1 and Study Group 12, and 802.1 is sending a response crafted and approved last week. I gave the link to the chat. The essence is silent is not consent, which seems to be misunderstood. We have Scott in the queue.
Scott?
Yeah, the liaison was sent by the chair of IEEE 802.1 like 10 minutes ago. So it's also addressed to the DETNET group, so I can get the IEEE response loaded in the IETF's liaison database as well for your information. That will help with your reply. Thanks.
That's great. And if it's addressed to our group, it'll pop up there for everyone to see. Thank you, Scott. I think everyone is familiar with our IPR process. This is just here as a reminder. We do a formal call at adoption, and before moving to working group last call, it's very important to disclose any IPR that you are aware of. I know that this has come up occasionally. I expect it to come up again. I know we have a document that we're going to do a last call on that has some IPR that we don't quite understand, so we'll ask for some additional information on that one. This is here as a reminder that the working group has resources available to you as participants. If you would like to set up either formal or informal meetings, we can support that. If you have a request for a topic to cover in an interim meeting, please let us know, and we can use those working group resources. And of course, as a reminder, The list is actually where we confirm consensus. So please continue to use the list, have good discussion there. This is, I failed to update this slide. This is the current process. So this is a reminder of a process change we discussed at the last meeting. The change is that we are asking for all authors of working group documents to either request a slot to present or to give us a status update at the same time that the submission happens, which is basically the deadline in order to get the agendas in. And the reason for this change is so that we have enough time, the working group has enough time to consider the status and prepare for this meeting here for any discussion on open items, even if the document's not being presented. So we think it's a really important process change. It is new, so there's a little transition from showing up at the meeting and giving something a little bit ad hoc, or sending mail the week before and not giving people really enough time to react. So we really want to emphasize that we feel that this change is important. And with that, I have finished the intro, and we're going to move on to Pascal.
Can you hear me okay?
You're very low.
Very low. Okay, yesterday was too loud, so you must have changed something. You can that.
Yeah, if you could do something to adjust your volume, that would be really appreciated.
Yes, well, it will take a second. Grab mine. Okay.
If you were talking, I'm not hearing you.
No, I'm adjusting the volume of my mic. Like I said yesterday, it was very, very loud in the room we were in, so I moved it down, and now I have to move it.
I think you've hit the right spot. You were a little loud for a moment, but the last thing you said was perfect. So if we're ready.
Okay, so let's move on. Can you display the slides, please?
The slides
Okay.
are
No,
being
next
shown,
slide.
and I think you have control. There you go.
Okay, so as you mentioned, there are two documents for the raw architecture. One is the architecture document itself, and the second one is the raw framework document, which has not been moving on, and there is actually a reason for that. The idea that we had at raw was to use the architecture to document what we thought we would be doing and use the framework to detail how we realized it. Like the framework would be able to document which RFC does what, how things are structured together. Whereas the architecture was more of a blueprint, meaning the architecture comes before the work and the framework comes after the work. So that's why the framework is not moving on, and we will need to progress on the raw items in terms of technical RFCs before we can really move on with the framework. So it will be expired. That's the intention. There is no much reason to just keep it alive at the moment. We need to work on the items, and then we can revive the framework. Now, if people have comments on the framework and they want some changes, we can always make them. So we just published 18 with Janos. So thanks, Janos. I mean, Janos has been reviewing this document and working on fine-grained details for a while now. I think we are reaching a very good level with this document. From my perspective, the main thing that has happened since version 17 is that we have rescoped a little bit the way we are doing things, the way we are saying things, to move from the raw charter, which was more open to, I would say, the wide internet, back to DETNET, which is more for local domains and tunnels and things which are more controlled. So we are kind of retrofitting this in the raw architecture, so raw now can remain within the DETNET umbrella. And as an example to that, there was this picture on the top left, where you could see that basically the idea was we have some access networks like wireless Wi-Fi or 5G access networks where most of the quote unquote wireless issues could happen. And then there was some backend network, which could be the internet or could be an enterprise network in an ESS or could be a 5G core. And the idea was we are not measuring the network on the right at layer 2. We are measuring basically the RAN, the radio access network, and then we are measuring end-to-end at layer 3. But we are not reobserving what is called the internet on this picture. Now, the discussion with Shanas was, hey, we don't support the internet in DETNET. We have to, but we do tunnels. We do, in the core, there are tunnels. More often than not, actually, in Wi-Fi, there are also LWAP tunnels. And through the wires are tunnels, there are tunnels everywhere. And we can effectively measure the tunnel, even if we don't really know what's going on in the substrate of that tunnel. So we changed the picture from what is on the top left to what is on the bottom right. And Janos had that additional question whether we should illustrate more than one tunnel just to show that the multipath can effectively have more than one tunnels. On the one hand, it will make the picture a bit more complex to read. On the other hand, obviously, it's more complete if you see tunnels, more than one tunnel. My idea is to keep the picture simple, but I mean, any comment is good to take here. Another example of something we changed. So this text in green here is gone, and probably there is another instance of that text I need to remove as well. But the idea was these were the words which came with the picture on the top left here, saying you can neglect what's going on the quote unquote the wires compared to the loss, for instance, or jitter that can happen on the wire. So the idea was if you have an IoT network, for instance, or even a Wi-Fi network, it may very well be that what happens on the wire is 1 or 2 orders of magnitude more visible, more impacting than what goes on the wire. So if the wireless is 99% of the contribution to jitter and loss, then we can ignore the rest of the world. That was the intention here, and it's gone. And you can see also on this picture on the top right, you see the tunnel instead of the internet. Same idea. We are eliminating every reference to the internet at large, but we conserve the idea that there are tunnels and we are measuring them. And you can realize that, like I said, this could be through the wires, this could be SD1, this could be all sorts of tunnels, and LWAP and CAPWAP and core, any sort of tunnel. So that's still the intention to support those tunnels. Another thing is, since we are more into DETNET and less into IoT, the kind of numbers that we are giving in the timing order tables is going down for 2-3 orders of magnitude, and you see the new numbers. I was on above where the idea was for the time scale of the RCPF, the idea was you recompute your routes like a batch system every so often, but you don't recompute the routes as soon as there is something wrong, because you know that row will have plan Bs, plan Cs, and so you don't have to recompute your routes immediately. That's why there was hours and above in the RCPF time scale. Now we're going to we can trigger a routing computation as soon as there is a problem, because we have more bandwidth between the routing system and the forwarding system. So we have basically changed the order of magnitude of numbers. That's really behind that. That's the change of intention, going from you don't recompute the routes immediately, you recompute them as a batch much later, or you do recompute them immediately because you have enough bandwidth for doing your control immediately, as opposed to every so often. And that's pretty much what I wanted to tell you, and the rest is the other updates that Janos has been proposing. So Janos, yes, I leave you the ball.
Thank you, Pascal. Actually, the first 2 bullets has been explained, so I'm not going into that one. More integration or better integration overall to the DETNET architecture. And as the third bullet says, I guess the major update was to update figure 5 based on the figure 3 added to version 17. Figure 3 is an expansion of the very simple DETNET figure showing the forwarding and the service sublayer and the location of row and row components. And figure 5 is the one that elaborates more in detail. So based on the changes happened to 17, there was the figure and the corresponding text had to be brought update. And there were some corresponding changes. This one doesn't work. Thank you. So this is the details on figure 5. The main change is that the point of the PLR, which is a point of local repair in TE terms, you can consider it as a point of local reaction, has been moved to the forwarding sublayer where the actual fast reactions happen. That's the point of the PLR. And also another terminology change is that asynchronous control plane framework ACPF has been replaced with local CPF. That was the idea which did not reflected by the old name. Asynchronous sounded like time sync, and it's actually the point is that it's local decisions making all the reactions faster. And to make the figure clearer in terms of the DETNET architecture, where the different components are, the soundbound interface has been added to indicate the data plane and the operational plane to make it clearer. Yeah. To the next slide. I don't know why this one doesn't. And this is another suggested change. Updates to the definitions of reliability and availability actually bring them closer to the cited NASA definitions where they come from. And I guess this is the last detailed one. Yeah, there were further smaller changes, like the previous draft used maximum consecutive failures, but actually maximum consecutive loss has been defined by the DETNET flow RFC. So the terminology has been changed to that one. And the last slide is makes the point that we already discussed. Lou explained that we are actually heading to the second working group last call. I have raised one more discussion topic on the list related to OEM, which we would like to see some discussion from OEM experts. My concern was that there is the in-band and out-of-band OEM definitions in the draft. I think it's not clear. I was trying to figure out something clear, and when I found the initiative in IETF suggesting not use these terms. So it would be nice to sort that out maybe before last call, but this can be part of last call as well.
Any comments, questions? As we move to last call, I think it is important to, this is to Pascal, I think it would be really helpful to go back and look at the comments that came in, particularly in November. I see at least my comments haven't been addressed in this revision, and I did not go and look at others to see whether all the comments were addressed. So I really appreciate all the work forward. This is clearly a really good step forward, but it would be good to make sure that past comments are addressed and before we head to last call. Pascal, if you feel that you have done that, please just send a message to the list saying that you feel that all comments on the list have been addressed, and then those who have made comments can re-raise them, and that would include myself.
Well, that's not the case, Lou. I have to go back to the list and make sure first that I have isolated all the messages, and I will answer you specifically.
Sure, I just double checked, but I don't mind resending the message to the list if that would be helpful.
Carlos, you are the next. It works now.
But thank you very much for the changes, and really look forward to wrapping this document up. Thank you, Pascal. All right, Carlos.
Okay, thank you very much. I'm Carlos Bernardo. I'm presenting this update on multi-domain extensions. As you see from the cover slide, I highlighted that it's not any longer raw specific multi-domain extensions, although in the draft the title is still raw. That's a mistake I have to update. But the idea here is that we are now trying to address multi-domain extensions from a DETNET perspective, not focusing only on the wireless specifics. In this presentation, I will focus mainly on the updates of the draft.
They're not able to hear you. If you can sort of get a, maybe just hold the mic, just hold it. Ah, perfect.
Okay, I hope now it's better. Sure. Thanks. So I was saying that this presentation is mainly focused on the update of the multi-domain extensions draft, but I will also present at the end very briefly some material on experimental platform and experimental prototyping that we are doing in a research project, basically addressing some of the DETNET related proposals and also the DETNET related drafts that we are bringing to the working group. That's why we also added Mark from Ericsson on the cover page of the presentation, although he's not an author of the draft itself. So going to the main point that the draft Bernardo's DETNET raw multi-domain, the scope originally, or the motivation originally, came because of the point that in raw we were not doing, we didn't do that much work focusing on multi-domain. Most of the work was focused on single domain. In DETNET, it's true that there are mentioning of multi-domain in different documents, but it's also true that we didn't really go into the details of looking at what are the gaps and what are the challenges that may involve, maybe may require supporting multiple domains. So that was the initial starting point. We realized that there are some scenarios that may require multi-domain. Initially, we were focusing on wireless, but again, also involving wired domains. Basically, scenarios where we may have a host connected to one domain, having a communication with a host connected to a different domain, and still requiring determinism requirements and availability and reliability. One simple example of one of these scenarios may be a large factory, but there may be others in which we have multiple domains because of organizational reasons, and you may want to have communications between the different domains. And be aware, or an important message is that now that we are broadening the scope to support also wired domains, by multi-domain we mean multiple administrative domains, so domains that are managed by different administrative entities. But even if they are managed by the same administrative entity, when we have a wireless domain and a wired domain, there are some considerations that make the scenario multi-domain, because we have different technologies or different solutions that we may need to adapt to support this type of a scenario. So the idea was to explore in the raw now the DETNET potential multiple domain gaps that may exist in the architecture, in OIM mechanisms, in other type of protocol solutions that we may need to support. And some of the requirements and the gaps are already partially covered in the DETNET controller plane framework that, as Lou mentioned, is close to be finalized, hopefully. But there are still some other things that we believe may require attention from the working group if there is interest in this type of problem. Doesn't move to the next one. No, okay, sorry. So this is a exemplary figure. Basically in the draft, now there are two figures. The original one that focused on multi-domain only wireless, and we added a new one trying to reflect the scenario in which you may have one domain on the top that is wireless, raw domain. Apologies because still using the old terminology with the PSC and all the stuff. I need to update that, but I guess for the sake of representation, it will work. And then at the bottom, we have a wired DETNET type of domain. So of course, the domains might be interconnected using multiple paths, and the domains may be wireless or wired. In case both domains are wireless, probably the connection between them will be wireless, and there may be a phase required to set up these links wirelessly between the different domains. And since the domains are wireless, they may be even mobile, and there may be things to be done to maintain those links or to dynamically update those links. This is out of the scope of the draft. we assume that there are some communication links between the domains, and the things that we look into the draft is how to enable using those links to support multi-domain communications with determinism requirements. And for that, we foresee or we identify that there may be inter-PCE or inter-control plane functionality work between the different domains, and also some inter-domain coordination between the different entities. And with that in mind, we did a first type of high-level solution. I will not go into the details here. They are in the draft, but the idea is that you have a host connected to one domain requiring some communications with deterministic characteristics with another host connected to another domain. The ingress node, DETNET or raw node in the domain 1 will require or will request the path towards the second domain that will be done to the people to the node in the second domain where the final host is attached to. That will get to the PCE of the first domain. The PCE of the first domain will know what are the PCE of the second domain or the control plane function. There will be some interactions there. Here there are some examples, basically requesting the different paths that are available between the different domains and the quality of the links that there are between them. That will allow the domain 1 to identify what are the nodes and what are the paths that have to be established between the two domains and in the second domain, and also do some kind of a split of the QoS. The SLAs required on both domains to be maintained on each domain to ensure the end-to-end SLA with the deterministic characteristics. Then additionally, we'll need to set up some OIM mechanisms of both domains to be able to react fast and in time to potential changes that may require changes on the per packet forwarding that is done at each of the DETNET and raw nodes on each of the domains. And that's basically the high-level, very quick idea that we have there, just as an example of potential things that we may need to do to support multi-domain in this specific scenario. This has been presented in the raw working group and the NetNet working group. The last time was in IETF 119, and one of the main comments that we got was that we should depart from the raw specific only a scenario and try to embrace also DETNET. So try to make it DETNET and not raw specific. This is something that we have started to do in the last revision. That this is the main change that I just presented. And as usual, the question will be from my side to see whether there is interest in the working group to address this type of problem, either with this type of document or in different documents or in different pieces of already existing documents. And if so, question will be how we should do it from the working group perspective, and also asking the chairs if there are feedback on how to do that. So I'm not asking for adoption of this or anything like that. I'm just asking, is there interest in this type of problem? And then if so, how we can address that. And then very quick,
before you move to this, I just want to see if there's any questions on the document, because this is, you're moving a little bit into a different topic.
Gino is in the queue. Gino, go ahead.
Thank you. Thank you, Bernard, for the presentation. Can you hear me?
yes.
Yes.
Oh, thank you. I think it is very interesting topic, but the diagram you just showed seems quite generic. Generic in the sense that any type of multi-domain network has to consider. Is there any specific requirements for providing deterministic performance? For example, there are many data plane solutions that we are currently pursuing. And based on that data plane solution, I think the control plane and the management plane operation themselves have to be quite different. So I'm just asking if you have any data plane solution in mind. Thank you.
Okay, thanks for the feedback and the question. So basically what we foresee is not that much change needed in terms of data plane. We can use any of the data planes that are specified by DETNET. Actually, we have a testbed already supporting multi-domain on the DETNET data plane, and this is something that will summarize in the next part of the slides. So we have already something working on multi-domain with 3 different domains using DETNET data plane. So here, what we foresee it may be needed is control plane extensions to basically synchronize the different domains to be able to have the information required at each domain to ensure that the end-to-end communication will meet the requirements from the deterministic point of view, latency, reliability, whatever is required. That's where we believe there is work to be done, not that much into the DETNET data plane, more on the control plane. And here, the diagram is kind of generic. It's a potential type of solution, but it's on the control plane kind of thing. So trying to interconnect and put in place the different mechanisms required to have this information for the setup of the multi-domain paths. I don't know if that addressed your question.
I think we should move on in the
Okay.
queue.
Yeah,
Kuan,
sure.
you are the next one in the queue.
Can you hear me?
Yes.
Yeah, I have 2 concerns. The first one is the same with Gino. It needs to clarify the specific DETNET development. And for Gino mentioned the data plane solutions extensions, we have some drafts to extend that protocol. And the second concern is that
I'm sorry to interrupt. While your initial question came through clearly, you're breaking up quite badly now. So I apologize. Perhaps put it in chat and we'll read it for you, if that would be okay. And we'll give you a moment.
Thank you.
Okay, thank you. And Shusong?
Hi, can you hear me well?
I think so. We'll see how the rest of it goes.
Yes, I want to confirm that Carlos have some very good contribution to the controller framework, controller plan framework document, and the multi-domain consideration has already been ended in that document. And the other point is that considering the framework document is just, a very general description of this part. So I think this work is still very necessary. And I noticed that there is some, protocol interworking that has been introduced in this work. I'm wondering whether there is any exact protocol that is in mind to be extended to, have this functionality.
Okay.
I think this is a question.
Yeah, thanks for the comment. Regarding the question, we haven't yet identified or selected a specific protocol per se. We try to identify the semantics required or the logic required, and then that will be part of the next steps for the working group if there is interest in working on this, and for us, either way, in some of the activities that we are pursuing, as I will summarize in the next part of the presentation, to select a control plane that we could extend, existing control plane that we could extend with the required extensions for the multi-domain. But here we are focusing on the kind of the logic, not really on the protocol specific points.
Okay, so in my understanding, you mean that the protocol will be kind of the next step of this work, right?
Yes.
Okay, understood. Thanks.
I'm assuming Kwan didn't want to ask her question here, and we'll ask it on the list. You
Okay.
have a few more minutes to go through the rest of the slides.
Yeah. Okay. Thanks.
Thank
So
you.
very quickly, because this is not the main point of the presentation, and I have some slides that I will go very quickly just for you to have the material there, and if there are questions, you can contact me offline or on the list, even better. So basically, we are working in a couple of projects. I don't know why I cannot go to the next. Okay, thanks. One of them is called data-driven, 6E data-driven, and it's basically looking into deterministic extensions to 5G and future 6E networks, so on the time sensitiveness side, on the reliability and availability. We are doing different things there. And by we, I mentioned the university I work with, that is UC3M, and also mainly Ericsson, Spain. For example, we are doing some stuff on the time-aware schedules. We have already an implementation of AO2.11 1QBB, and they are working on the 2.1 QCR implementation. There is also some AI-based digitering solution to improve the performance and avoid the need to modify packets on the path. Then on the reliability, availability, more on probably on the DETNET things that have been done here already on the data plane. For example, we have an implementation of the FRARE in a multi-domain environment. That multi-domain environment comprises an Wi-Fi Intel extended base. It's a Wi-Fi experimental Wi-Fi 7 Intel-based setup with deterministic extensions. We have a commercial TSN setup with several switches, and we also have a 5G domain. In the 5G domain, we have a couple of variants. We have one based on the Exxon pre-commercial hardware, and we have another one based on open-air interface. So basically, with these three different technological domains, we managed to have end-to-end determinism to some extent, of course. And on the data plane, this is already implemented, and we are now working on the control plane required to dynamically modify this, maybe according to the draft I presented or according to whatever the working group does if the working group goes into the multi-domain extensions. Some of these results regarding the multi-domain, but we are also doing other things like mobility and some other stuff, are being evaluated and validated through, of course, academic papers, and there are some examples there, and also and some industrial demos or some kind of prototype POC, proof of concept. For example, one that we are doing on a smart factory industry 4.0 scenario in a sister project that is the Predis 60. And then the next slides, please, can you go to the next one? Are presenting some of the stuff we are doing. I will not go into the details. For example, we have a software switch that was developed to allow us playing with all the DETNET data plane that support the traffic classification, switching, routing, the QBB support, this smart the jittering that we are doing, and some ongoing work. This is just to make you aware that we have this type of support available, and we could even get in touch for maybe reducing part of this in other efforts. Next slide, please. We have also the QBB schedule implemented, and we are playing with that and how to complement that with other slicing techniques that we can use to prioritize some traffic over other traffic. And then we also have, next slide, the FRARE implementation, where we are playing with some stuff that is not standard compatible. We are playing with extended RTAG that breaks not one CFB actually, but we are playing on what we can achieve in our particular implementation with this additional extended RTAG, where we have a timestamp field that allow us to measure and to do the elimination in a different way. And I see that, Lou, you are on the...
Well, I'll wait for the end.
Okay. And then go to the next one, which is actually just the acknowledgements. And this is a set of things that we have. I plan to send on the mailing list when we have public documents going into more details on all these things and open source that we may release. But just for you to know that we are doing things on the DETNET implementation in different environments. One is multi-domain, and that may be relevant for the working group. So feedback is always welcome.
Okay, I'm going to read a comment from Kwan. Two concerns for multi-domain with PCE. One is that it needs to clarify the specific requirements for DETNET. The data plane solution, which Jinu mentioned, has been discussed in PCE extensions and other individual drafts. The second concern is that what is the difference between interdomain and multi-domain for DETNET? I think that's a good question because for example, the PCE documents that have been done talk about interdomain, not multi-domain. So that's Kwan's question. I don't know if you want to answer.
Yeah, on the interdomain versus multi-domain, I guess the main is a terminological probably question. So I don't know if I will get the point correctly, but interdomain is when you have domains that you have to interconnect, not necessarily having domains that belong to different administrative domains, potentially. And here we are supporting both. So I'm using multi-domain, but we could use interdomain, because if we have multiple domains or a couple of domains or 3 domains that belong to the same administrative domain but have different technologies, we still require some additional mechanisms. Because as far as I know, with the today DETNET architecture, we don't have mechanisms in place to support this. And if, in addition to that, we have multiple domains from an administrative point of view, we also have all the stuff required to the authentication, authorization, all the administrative part to put into, to integrate multiple domains. And that's on top of the interdomain, we have this multiple domain stuff that we need to tackle.
Okay, thank you. Shusong, you're going to be the last in this session or this slot.
Yeah, Carlos, actually, I think the last part you have shared about the project is very interesting. I noticed that the previous rule work is mainly about the, you know, the Wi-Fi wireless consideration, and this time you mentioned some, you know, 5G or 6G related work. I think it's a very good choice. So my question is that whether this project is also, you know, related to the mobile standard work, for example, 30pp, or is just, you know, still a technical project that is, you know, only discussed about the technical implementation.
So can you say again the last part, because I missed the
whether this also have some relationship with the standard, other standard group like
Yes.
30pp, or it's just, you know, technical project in the existing stage.
Yeah, although we don't have an actual delegate kind of going to 3GPP. Basically, we are assuming what 3GPP has done. So far, we implemented the latest releases in terms of DETNET support, and we are then looking at how to integrate that with multiple domains and whether there is something required on that side as well. So we are not going there. We are doing our kind of standard dissemination path through IETF mainly. But the idea is to look at the multi-domain problem, not only from the IETF side, but from all the SDO side, although 3GPP is using DETNET, that's the solution that they have for that. So we believe that by going through the IETF, if there are other changes required, we'll go to 3GPP as well.
Right. Thank you for keeping us up to date in this work. I suspect at some point we will get to an adoption poll, but you're not asking for that now. You're just asking for an update. But if you could take the comments that you've heard here and do another update, that would be appreciated. I think Shusong said something really important, which is that the multi-domain implications that you've raised have already been incorporated into the control plane framework. If you can also look at the other documents like the raw architecture and make sure that multi-domain or interdomain is captured there as well, that would be helpful. So thank you, and we look forward to hearing about this in the future. With that, Janu, you're up.
Thank you. Okay. Yeah. This is I'm Jinu Zhang, remotely joining. And this is data plane enhancement taxonomy draft. So the summary. It was adopted as a working group draft on May. So the initial version was created on May as well. And it has been updated to the version 1 on July. The only update in version 1 is the addition of the reference topologies. As you can see, as section 6, it has a brief, a generic description on what reference topology is, and one exemplary reference topology called grid. I will briefly explain about the reference topology. So why we need reference topology in the taxonomy draft? Because taxonomy is taxonomy, and reference topologies is quite a different thing. But we are still having two different things in a single draft. Why we do that? because there was a strong comment from the previous meeting. And I think, and we think, the authors think, the reference topologies are to evaluate the data plane solutions, how they perform in real situations in terms of end-to-end latency bound and jitter bound. So the scope of the document has been quite expanded a lot, and I think the reference topology can profoundly impact all the other comments. So we have decided to focus on the RT only in this revision. Yes, there are, please note that there are unresolved comments from the previous meeting. As you can see, as follows, you can take a look. But it is not addressed in this revision. So before going further, I would like to define clearly what reference topology is. A reference topology has to consist two things. First, the network topology, and second, flows characteristics. The network topology specifies the abstract locations of source, destination, nodes, and their interconnections. This is a conventional definition of topology. Second, the flow characteristic has to be included. The flow characteristic is about their path, their requested performance specification, we call it RSpec, and traffic specification. RSpec may include end-to-end latency and jitter bounds. And TSpec includes the maximum burst size and the average rate, as if they have been shaped by a token bucket. I think this is a very important specification in order to get the performance numbers. Or alternatively, a flow can be specified by the period and the maximum burst size. So there are two alternatives of the TSpec. Actually, I'm not seeing the time passing through. But okay, anyhow, I will just go on. So this is until so far we have specified about what RT is. Here from here, we have presenting exemplary RT called grid. It has 9 nodes placed in a grid, and there are 6 sources and 6 destinations placed like that. It represents a general network of partial mesh or grid topology without considering a specific use case. So it is very generic topology. One thing unique in this topology is that the links are unidirectional. So the direction of the link follows the blue arrowed path. The flows should always follow the blue arrows. And the capacity of all the links in the topology is 1 gigabit per second. Why we have chosen such a topology? One of the main reasons is that we would like to have cycles in the topology as shown as the red circles. There are 4 cycles in the topology, and these cycles create burst accumulation, especially when a simple scheduler is used, such as FIFO or strict priority scheduler that is used in DiffServ architecture. In this topology, when the network is highly utilized, such as simple schedulers do not guarantee end-to-end latency bound. So we would like to see whether our data plane solutions can guarantee end-to-end latency bound in such a kind of complex topology. That's the main reason. So I just presented the network topology. From now on, I will talk about the flow specification. While the network topology itself is very generic, we would like to have a very specific flows and their specifications. So we have examined the right choices, and among those, we have chosen the flows used in the in-vehicle networks. There are some references you can see in the slide, in the last slide. In those references, the observed flows for deterministic services in in-vehicle networks are of three types: audio flows, video flows, command and control flows. They have such characteristics. For example, video flows are very bursty. As you can see, as many as 30 maximum length packets are emitted at once. We call this as burst, right? And this burst emitted once in 33 milliseconds. So that's the period, and so on. And based on the application, the deadline or the end-to-end latency bound is 10 or 30 milliseconds. So this is quite strong deadline, I would say. And so on. And there are many different CNC flows. For example, they can have about 50 bytes or 300 byte packets, and their periods can vary from 5 to 80 milliseconds. So this kind of observation has been reflected in our document, that the flow types are simplified. Audio, video, CNC flows are simplified and abstracted into these parameters you can see in the table 1. But we can say that maybe we have oversimplified, especially the CNC flow. This can be enhanced in the future version of the draft. Because as you can see, there are various types of CNC flows, but in the current form of the RT example, we have only one type of CNC flow. Okay, so in order to simplify further for the simplicity of analysis, the flows that I just shown in the table 1 has been aggregated with roughly 1 to 10 ratio. So here they are not called audio, video, CNC, but just they are called flow type ABC. And their maximum burst size has been increased 10 times, as well as the arrival rates. But the maximum packet length and required maximum latency remains the same, and so on. Yeah, I just briefly mentioned about the flow characteristics. They're T-spec and R-spec. Finally, how the flow choose their path. This should be very simple, but in fact, in our example RT, it is very complicated. So I don't want to spend too much time on it. You can take a look the slides. I will just go through very briefly. Simply put, there are 36 flows overall, because each source generates a flow to each destination. So it's 6 times 6. So there are 36 flows overall. And each flow type has specific destination node. For example, type A flows are destined only to destinations 1 or 6. So in this figure, in the lower left side, you can see the blue flow from source 1 to destination 6. it has to follow the unidirectional links from node 1, 4, 5, 8, 9 to destination 6. And this has to be type A flow because it is destined to destination 6, as you can see in the table 2, and so on. And this is a little confusing to make you understand at this very moment. But in short, we have some rule. We have some rule for flow path diffusion, and if we follow that rule, that gives the unique path, at least in this topology. Okay, so this is the example flows of flow type A, flow type B, flow type C, and these three flows colored in blue, green, and red are of their maximum hop counts. So from source to destination, these flows hop count is 7. And as you can see, there are cycles these flows are forming. So with a simple architecture like DiffServ, there is no guarantee of latency bound. Okay, and finally about the utilization of the network. Here the bottleneck link is between 2 and 3 and between 8 and 7. These two links are the bottleneck link. In the bottleneck link, there are 1 type A flow, 5 type B flows, and 2 type C flows. I would say type B flow represent the videos, so it is very bursty. Having 5 very bursty flows in a link is a big burden. So normally in this situation, guaranteeing end-to-end latency bound is very difficult. And the network utilization about 53%. Okay, a future plan. I think as we have discussed in the previous meeting, we have to solicit more reference topologies, maybe 2 or 3 total, and fix them and evaluate the data plane solutions with these reference topologies. The performance metrics should include end-to-end latency bound and end-to-end jitter bound. And maybe average latency should be included as well. And maybe more importantly, the configuration complexity with dynamic flows join leave situation, how each data plane solution can handle such a dynamic situation with less complexity. They can be evaluated as well. There's the major future plan. And we will also resolve the comments raised in the previous meeting and during this meeting comments. Thank you. I hope I have met the time deadline. Thank you.
Thank you, Gino. Yeah, we are over time, but we have one question. Let's have that quick question, Shafu, and then move on to the next one.
Hi, Jinu. Thank you for the presentation. Yes, for the video flow, there is a bus. There is a different term, the audio and the CC flow. So just wanted to confirm that for the bus of video flow, do you want to regulate it under network entries node by a token bucket?
Oh, thank you for the question. Yeah. When we say T-spec, we have to specify the maximum burst size and average arrival rate, and maybe additionally maximum packet length. These are 3 very important parameters of T-spec. If we cannot specify these 3 parameters, then we can say that we don't know anything about the flow itself, how the flow looks like. So these three parameters are very important, I think.
Okay. Thank you. Okay. I will discuss in the bare list.
Yes, thank you.
Okay, Janu, I have two different topics. The first one is thank you for the really good work and the update. I believe there were comments made at the last meeting at 119 that have not yet been incorporated. Is that correct? And if so, what is your plan to address those comments?
Yeah. I have showed you 6 or 7 comments that is not resolved yet. I'm not sure. Soliciting more reference topology is more important, I think. But at the same time, some of the comments can be resolved parallelly. Those comments will be resolved. The authors will discuss about those comments and try to resolve as soon as possible.
Okay, thank you. It is reasonable to say that you are going to address them after getting in the reference topologies. That's a reasonable approach if that's the author's their approach. Just good for the working group to know. The other comment is I'd like to highlight this last slide. What we're trying to do here with the taxonomy is give us a framework for evaluating the different solutions. So this third bullet is pretty important, and we are hoping that once we have the taxonomy sort of flushed out, and including addressing the comments from the last meeting, we can go and look at the different solutions and help categorize them and sort of describe them in a way that allows the working group to decide which of those we'd like to advance. So this is really important work, and we appreciate the work that the author team is doing. And thank you for the presentation. And from the working group, please continue to comment. Thank you. So next.
Okay, thank you. I will focus on the evaluation. Thank you.
Thank you so much. Appreciate it.
And yeah, I will present the C-score draft. Thank you for the comment. I will briefly introduce the history of the C-score. It has been included in a different draft called ADN framework for large-scale networks. The ADN framework draft has been initiated like 2 years ago. And C-score was just one of the asynchronous data plane solutions introduced there. There has been discussions, revisions, and so on, but there was a request from working group that C-score has to be separated as an independent draft. So it happened. Like 1 year ago, more than 1 year ago, this draft has been created and has been through intensive debates, discussions, and revisions until the previous meeting. However, after the taxonomy draft has been introduced, there has been no comments at all, no single comments. So in this revision, only the minor editorial updates and the titles has been revised. The editorial updates are very minor. I will just briefly introduce. The definition of an entrance node has been added. It is the edge node through which a flow enters a network. That is called entrance node. And it has been specified that C-score is based on the virtual clock. This sentence has been added. The document adopts the virtual clock's approach. Of course, the descriptions and explanation about what virtual clock is already there. And the concept of system potential, which is equivalent to virtual time, has been completely removed because these two concepts are same thing and don't need to be repeated. So it has been removed. And the following has been specified that the service rate should be chosen to be larger than or equal to the arrival rate of the flow. So these are all minor editorial updates, I would say. And this has been updated as well, that it has been emphasized that the complexity in the entrance node can be mitigated by adding more sentences. The yellow highlighted part is what has been added. I think you can take a look. In summary, the entrance node functionality can reside in the source itself, and that's how the complexity of the entrance node, which has to keep the flow state, is greatly mitigated. And the subsection titles are revised slightly. I should have shown you the old titles, but I forgot to do that. Anyhow, the revision here is to reflect what the subsections are trying to do. So it's more explanatory subsection titles. They explain better what the subsections are trying to do. Yeah, that's it. I think the draft is now stable. And in the future, when the reference topologies of the taxonomy draft become stable, this score will be evaluated and will be compared to other data plane solutions. And if that happens, I think, I hope work group adoption will be done maybe in the next year. And after the adoption of this draft, a new draft for end-to-end jitter-bound guarantee will be presented. Remember that the C-score, the current draft, is about the end-to-end latency-bound guarantee, right? So there is another solution, completely orthogonal, independent solution that can bound jitter guarantee. And that will be presented in the future. Thank you. Thank you very much.
Any questions, comments?
Okay, next up is Shafu. You have 10 minutes.
Hi, this is Sofoper from ZT. I will present the data-based forwarding mechanism.
You have control. You can flip the slides.
Thank you. I just control it. So yes, in this vision, we just have some minor updates from version 9 to 11. For antenna mode, we supplement the fig of ED decoupling with two-tile schedulers for easy understanding. And correct the misleading drawing in the fig example of Polyson and the network entries node. And the third, reconsidering the frequency synchronization. So this fig shows the internal components of ED decoupling operation with two-tile schedulers. The packet is scheduled by pre-scheduler configured with untimed mode based on the latency deviation E, and then scheduled by the post-scheduler configured with in-time mode based on the planned residence time D. The pre-scheduler may maintain a FIFO article or a PIFO. So this is the second update. Polyson and English is important for the success work of EDF. So this figure shows the flow pattern after polishing that is different to the original flow pattern when received and the incoming interface. The time when the packet departed the regulator and arrived at the scheduler is termed as arrival time S, which is used to the enqueue operation. That is the time arrival time S, which queue or buffer position is appropriate for the packet to be inserted. So the third application is about the frequency synchronization considerations. In theory, word or node synchronization of crystal oscillator frequencies between devices may affect the EDF's computation of residence time compared to the nominal time. However, on each node, the latency error caused by the clock rate from its nominal rate, for example, minus 100 ppm, is generally in the nanosecond range and can be ignored. For example, for the planned residence time 100 microseconds, the latency error by minus 100 ppm may be approximately 10 nanoseconds. So 100 hops only accumulate 1 microsecond. So this is a review of CEDF taxonomy analysis for its understanding its feature. CEDF is a non-periodic asynchronous class level worker conserving, non-worker conserver configurable, in-time and on-time configurable, delay-based scheduling scheme. And the probable latency dominant factor is delay level itself. We will further evaluate it based on the reference topology later. So this is the presentation of this slide. Any questions and comments? Thank you.
Any questions? Okay, thank you. I think you're also the next presenter.
So, okay, the next presentation is about the TGF mechanism. Firstly, we will report the split and give a quick status update. According to the received comments, the original draft is divided into two documents. One document for the data plane, and we use the original, and the other for the controller plane. This slide focuses on the data plane. The main updates from version 6 to 8 contains some editorial text reflecting the characteristics of TKF and supplement the BOM detection method reference. That is a stamp extension. And supplement the encapsulation of time slot stack method reference. That should be compressed due to explicit root of DETNET flow. So this is a review of TGF mechanism, and there is no significant updates. We use OPL, the attribution period length, to identify the related TGF instance enabled and linked. The attribution period is similar to the gating cycle of TSN TIS. All nodes links within the DETNET path interwork with the same OPL. For the same OPL, different links may configure different time slot lengths. For example, the edge nodes and core nodes may configure different time slot lengths. TKF instance may instantiate the scheduling period that construct less number of slots than a transition period based on the hardware capacity of the device. TGF instance may further configure in-time mode for low delay or on-time mode for low jitter. It should be noted that the TGF is a layer 3 solution and can operate over different types of QoS sensitive layer 2, including TSN. For example, release confirming traffic per slot to the layer 2 network. TGF is not an alternative to TSN. So for the BTM or POM detection of a unidirectional link, a stamp extension is defined. Based on the BTM or POM, a DETNET flow may be assigned outgoing time slot on each link and obtain FTM that has bounded latency. For the encapsulation of time slot ID stack, we have two basic design considerations. One is that on each link, time slot ID is used to identify the time slot resource, and it is better to decouple time slot ID and any type of topology instructions, such as IP address, MAC address, MPS label, SRv6 seed, to save topology instructions and the related signaling advertisement. The second design consideration is that the encapsulation should be compressed to support explicit loads of DETNET paths, as well as flow interleaving and core nodes by the time slot ID stack. So two possible compressed encapsulation methods are defined. One is short index based, and the other is common prefix based. Okay, so this is a review of TGF taxonomy analysis for its understanding in its function. TGF is a periodic frequency synchronous class level, work conservant, non-work conservant configurable, in-time and on-time configurable, time-based scheduling scheme, and the probability dominator factor is the time slot offset of FTM. So this is the presentation of TGF. Any questions or comments? Thank you.
Questions, comments?
So a request, the next time you present, if you could include some feedback or just a summary of the discussion from the other working groups. I think you're presenting also in 6-man and maybe IPPM. And if we can get updates of what's happening in those groups as part of the presentation, that would be, I think, helpful in the future.
Okay, thank you.
Thank you so much. Kieran, I think we're up to you. Kieran, you look a little different today. Kieran's in the room, but we have Luis.
Carlos, right?
Yeah, right.
So hello everybody, this is Luis. I will present an update of the draft on behalf of my co-authors. And the topic is about using deterministic networks for industry operations and control. Next, please. So the idea of the draft was to focus on the UNI, so how we can, from the application perspective, request flows that could be according to specific deterministic characteristics. And the idea would be to explore that kind of APIs or interfaces in such a way that we can somehow request that from the application side, let's say. And the idea with this would be to being able to provide some information to the to the network so that the network can reserve the necessary resources for enforcing the expectation of the application in terms of performance and the deterministic behavior in general. Next, please. So as an overview, this is the version 04 of the document. We already presented in the past the document. In IETF 117, we go through that and providing some background and motivation for it. So somehow we try to cover the gap of this specification, how the application can somehow request the services. Also, we introduce some types of traffic patterns that we have now reviewed in the new version. I will comment later on. And at that point in time, we were working on with the idea of proposing some extension for IPv6 header so that we can embed it in that extension the way of how to specify the flows. The feedback that we received at that time was some concerns about the usage of some extension headers. This was identified as a risk. Not a risk, as a question mark how to go through that. We also were requested to have a tight alignment or better alignment with the TSN work, and also to simplify the suggestion of simplifying and maybe reorienting the draft so that we can concentrate on the specific purpose of the UNI. Next, please. So with that feedback, we start working on the new version. New version is number 03. In this version, we have removed the extension header. This has been passed or moved to the appendix, so we yet have this documented, but there is no emphasis on that. So it could be a potential way of doing that, but not necessarily the unique, the only one way to do so. And also we have added, or we have revisited the traffic types that we identified in the past, and we have aligned them with the specification, the IEC IEEE 60802 TSM profile for industrial automation. In that specification, there is a specification, let's say a detail of the different traffic flows we will see later on. So we are taking those and considering those as the ones that we can apply in the document. So no reinventing the wheel, reusing what is already there. Well, there is here a screenshot of what could be the different traffic of interest. We will see that there are two more about best effort, but that would be basically the ones requesting or requiring deterministic behavior. Next, please. So going into the detail, these are in this table, you can see the different traffic types. On the column of the traffic type, the ones that are defined in the IEC IEEE specification, asynchronous, cyclic synchronous, cyclic asynchronous, network control, alarms and event, and configuration diagnostics. That would be the ones requiring some determinism. And then two type of best effort flows, best effort high and best effort low. What we have considered here, a part of the way of identifying the flows, that is also part of the IEEE specification. We have defined, we are proposing the number of parameters in order to specify that API that could allow the applications to request the specific behavior. So for asynchronous, the different characteristics that the application controller, in the case of the traffic flow is asynchronous, does not require to specify the clock source, and also there is some tolerance to the packet loss rate. For network control, the idea here would be to control the capabilities of the network, loop prevention, topology detection, and time synchronization. For alarms, clearly the performance monitoring, and for the diagnostics, basically to deliver packets time to time and collect the device configurations. Next, please. So we are proposing this kind of APIs. It's an initial proposition. Probably we need to go more in detail and understand if this is the proper one or we need to revisit. But basically what we are proposing in the document are different API formats, considering the traffic type, considering the deadline limit, different attributes, the deadline limit time unit, application flow reference, the clock source for whatever traffic type that requires the identification of the clock source, burst limit, retransmission, and so on and so forth. So different properties that could apply to these flows so that the application have a full suite of capabilities for expressing the the need of the flow before entering the network. Next, please. So, and the idea as well would be to be agnostic from the way in which we can enforce, let's say, this. We can specify, we can provide the specification of the flows to the network. This could be done out of band or off path. So via a controller using young models, and so how the controller is the one that can define these the different traffic types and prepare the network for supporting them, but also could be used in band so that we could have the signal on path and the application could express their needs. The extension headers or additional service layer are potential approaches, as said. So we keep yet in the annex the description for the IPv6, but we can revisit that. And just to mention that framing in some existing projects, we are planning a POC. The idea would be to leverage on P4 for playing with the headers and so on, trying to somehow provide a conceptual validation of the idea. This is yet under analysis, and we need to see if it will be ready for next IETF or maybe for the for 1-to-1 or 1-to-2. This is yet a plan, so we need to do the complete plan. And I think that that's all. So yeah, thank you.
Thank you. Antoine, please go ahead.
Hello, Antoine Sanko. I have a question regarding the data plane agnostic approach. Here you have apply out of band, where basically you have a controller sharing the control information. Then the second solution is you have an extension header carrying the information. Did you consider using like RSVP for traffic engineering and carrying the specification of the flows in a control message that is not coming from a controller but distributed in a decentralized fashion, but not in the data plane?
We have not entered yet into those details. Could be a matter of consideration. We have not considered. We are not discussed yet that point, but could be a potential option. Yes.
Okay, thank you.
Thank you.
Any further questions, comments?
Okay, thank you for the update. We look forward to your next one. I think you said it might be one meeting, maybe two, but look forward to it. Thank you. And we are actually on the last slot of the session. We will have a couple of more on Thursday. Balázs.
Hi, good morning. My name is Balázs Varga, and in this presentation, I will speak about a new DETNET data plane, and it is based on the SRv6 technology. The slide set is practically a summary of two drafts, because we have uploaded two drafts, one to the DETNET workgroup and one for the Spring workgroup. The DETNET workgroup related draft is describing all the details about the DETNET data plane, as we have defined for IP MPLS data plane. The other draft uploaded to the Spring workgroup is a description of the pre-of seed, because in order to support DETNET, you need a specific seed in order to include in the IP header the sequence number information, and the Spring document is describing the SRv6 behaviors according to the rules and descriptions of Spring. So this is the relationship between the two drafts. When we are just looking to the data plane history, then in the deterministic networking architecture, we have defined the two sublayers, the service and the forwarding sublayers. And the first DETNET IP data plane, it was intended to be a universal IP data plane for DETNET, which works for both IPv4 and IPv6. And unfortunately, there were a limitation regarding that, because there were no option in both protocols to add the sequence number information that is needed for the service protection functionality. So in RFC 8939, there is a limitation that the DETNET service sublayer is not supported by the DETNET IP data plane. This is something that was worked around in a recent RFC 9566, which is practically combining the DETNET pseudowire and MPLS over UDP technologies in order to allow pre-off functionality and the service protection for the IP data plane. However, this draft assumes that at some level, you are supporting some MPLS functionalities on the node. So it was not a native IP solution for the pre-off functionality. Regarding the DETNET tool sets, practically there are three tool sets that we are using: resource allocation, service protection, and explicit rules. In this slide and in the draft, we are focusing on the latest two, on the service protection, how to provide the pre-off functionality, and it is usually combined with explicit rules. So it is something that can be combined easily in the SRv6 technology. If we would like to have a native pre-off support in IPv6, then the task that have to be solved is to add the sequence number to the IP header. And the option that we have described in the draft is reuse existing IPv6 header fields. This slide is practically summarizing the three major building blocks that we have described in order to create the DETNET SRv6 IP data plane. So first of all, there was a new DETNET specific seed format defined, and that is capable to contain the sequence number information that is used by the pre-off instances. The second building block is that we have described how to place in the argument field of the seed the flow ID and the sequence number information. So this is practically defined the DETNET specific seed. And the third block is about to define the seed behaviors for this DETNET specific seed that we are intending to use in DETNET networks. There is one endpoint behavior defined, and there are 4 policy header behaviors defined. In the segment routing architecture, if you're speaking about SRv6, they are stating that the seed is represented by a 128-bit practically. And there are 3 parts of that seed. There is a locator part, and this is what is practically pointing a specific SRv6 node. In our case, this will point to the DETNET relay node, which is the next DETNET relay node on a path for a given flow. The function part, this is practically describing what functionality you would like to execute on that specific node, which is defined by the locator. And here, that function that we are looking for is the pre-off functionality. So with that function, we can point the pre-off functionality of the specific SRv6 node. And the third part, and this is very interesting for us in DETNET environment, the arguments field. This is a field that is optional, and this is where you can place arguments for the function. And in the case of pre-off, these are practically the flow ID and the sequence number information. So this is what we will focus on in the next slide. But before doing so, maybe let's make a short calculation. So how many bits we need in order to place these 2 arguments for pre-off in the seed. Looking to the flow ID, this is what is specifying the DETNET flow the packets belong to. And if we are speaking about the DETNET MPLS data plane, then we have defined a 20-bit flow ID in order to do that. In order to be compatible with that, practically, we are proposing in the SRv6 environment also use a 20-bit flow ID, because that makes more easily to change technology domains if you have multiple in a DETNET domain. Regarding the sequence numbers, they can use up to 28 bits. There are various sizes defined. So that means that the maximum size of these parameters can be 48 bits. And if we are looking to some recommendation in RFCs, in drafts about SRv6 technology, then the common example is where you have a 64-bit locator information, 16 bits function discriminator, and practically there are exactly 48 bits remain for the argument parts. So that means that the flow ID and the sequence number fits perfectly to such a allocation of SRv6 seeds. This slide is showing practically this DETNET specific seed. So you have the locator. In our case, this will point to the next DETNET relay node. We have the function part. This will practically say that on that next hop, DETNET relay node, you intend to use the pre-op functionality. Even just with a single value, you are fine in order to point to the pre-op functionalities. And in the arguments, you can place the flow ID and the sequence number information. And here, this figure in the right corner is practically showing a 16-bit sequence number example, how to place those information in a DETNET specific seed. One important thing to highlight is that in case of the pre-op functionality, if your argument is 0, that can be also a meaningful value, because it can refer to a flow ID 0, and the sequence number is just going around, because we have a circular sequence number space, and 0 is also a meaningful value. So this is something worth to note here. If you have already this DETNET specific seed, then you have to define also the SRv6 behaviors, and these behaviors are described in detail in the Spring document. And we have one endpoint behavior defined, and we have 4 policy head-end behaviors defined. Regarding the setup of the segment list, it must be noted that the DETNET specific seed must be the last segment in the segment routing policy. And that is coming also from the fact that this DETNET specific seed is defining your next DETNET relay node, where your SRv6 tunnel will be terminated. So that is the reason why it must be the last one. And of course, it is just providing the arguments for the pre-op functionalities. Okay, let's highlight what is really needed in the case of your endpoint behavior. If you have an endpoint, then this is where you will decapsulate your SRv6 tunnel. And practically, because your functionality will be the pre-op functionality, the red highlighted part is something related and specific to the DETNET pre-op seed. You have to extract the argument part of the seed and hand over it to the pre-op functionality together with the payload of the SRv6 tunnel. So with that, you can ensure that the pre-op functionality will have the payload, and it will also have the flow ID and the sequence number information, which can be used by the pre-op functionality in order to find out which pre-of instance to execute on that particular packet, and whether it was already seen or not, and so that is practically what is needed for the pre-of functionality. There are 4 encapsulation related behaviors defined. This is where you are starting your SRv6 tunnel to the next DETNET relay node. So here you have already executed a pre-of functionality, and from that you will know the flow ID and the sequence number related to the packet. And then you will have also a segment list, which is describing your explicit path over the network. And this segment list put together with the DETNET specific seed will be placed in the segment routing header. The last seed is always the DETNET specific seed. So the argument part for each packet have to be updated with the flow ID and the sequence number information, because that is always packet specific. And the rest of the encapsulation is practically very, very similar to other encapsulation related segment routing policy behaviors. We have a very similar functionality defined for the case when you have layer 2 frame as a payload in the DETNET domain. And in that case, again, you have to create your segment list, update the argument of the last seed, the DETNET specific seed in the segment list during the encapsulation, and placing the information in the segment routing header information. And of course, you do not have a TTL value, and you have to set the next header value to your layer 2 encapsulation. So these are practically the DETNET specific seed related behaviors that have to be defined. And there is also an interesting chapter in RFC 8986. This is about the counters. They have defined that for each of the seeds, you have to create a pair of traffic counters, one on a packet level, one on a byte level. And that is something that can be very useful in SRv6 environment. We think that for pre-of, we have much more detailed counters for the pre-of functionality, because if you would like to implement those functions, you need those counters anyway. But in order to be in line with the intention of RFC 8986, we propose that also for the DETNET specific seed, these counters should be created. That can give, those counters, for example, can give also information about all the DETNET traffic which is handled by that DETNET relay node in the network. So that makes sense to have those counters for the DETNET specific seed as well, and it is in line with the already defined behaviors in the Spring work group. So this slide is just showing the summary. What are the basic building blocks? The DETNET specific seed, how to encapsulate in the argument part the flow ID and the sequence number, and what SRv6 seed behaviors are related to this DETNET specific seed. That's what we intended to show. Any comments are highly welcome, and we will be also happy to work with other people to evolve further this data plane.
We have Shesong in the queue. Go ahead.
Hi, Balat. Thanks for the presentation. I just want to remind that there has already been a working group document for this topic in Spring Working Group about 2 years ago. The background is that In that stage, Spring Working Group has a very similar work, which is about replication segment for multicast, and that document has already been published as RFC. And in parallel, we want to introduce some, DETNET protection mechanisms in Spring Working Group based on SRv6 data plan. So we have this document, and there are some very good discussions in the mailing list. I think DETNET is also included, and the working group think this is very mutual, and the document has been adopted. So I think a possible proposal is if you are interested in this topic, maybe the work can be based on the existing work in Spring Working Group.
Yeah, thank you very much for that comment. So I think that's interesting to highlight that there are significant differences in my understanding between this draft and that replication seed. The replication seed solves only some of the functionalities that we need for pre-auth. So this is where I see the differences. But I definitely agree that this is something that we have to discuss further and see and list explicitly the differences and how they can be combined in the network. So I think they are not prohibiting each other. Both seeds can be used in a network, and I see somewhat different use cases for those seeds.
I noticed that there is some comment from Janos about there is some description in the background part for the existing document in Spring. And I want to clarify that in the first stage, we want to, put the work in DETNET Working Group. But at that stage, DETNET Working Group was focusing on the data plan based on MPS and the native IP header. So it is considered that the SRv6 based work maybe still not mature enough for DETNET Working Group. So we bring that topic to Spring Working Group based on the DETNET Working Group suggestions. So to clarify this working group's relationship, we keep this sentence in the introduction part. So, but actually, the functionality and the problem that should be solved for these two documents, I think, are quite similar. Although the document about the re-auth functionality is not, published as RFC in DETNET Working Group in that time, but the whole idea is quite similar. So I think I would like to propose the authors of these new documents to at least review the document and clarify the relationship.
Okay, thank you.
Mm-hmm.
Rakesh, please.
Rakesh Gandhi from Cisco Systems. So there are two fields added in SRv6. One is flow ID. So IPv6 already has a flow label. It's also 20-bit. So have you looked at using the flow label? Because it's not, it's typically used for ECMP, but it doesn't apply here. So have you considered using the flow label from IPv6 header itself? And the second question is that this is the DETNET seed is in the DA, I believe, destination address. If you're doing some kind of seed compression, there could be implications. So have you thought about putting those things in the source address for the DETNET?
Yeah, thank you. These are exactly the comments where I intend to have some further work on this draft. So regarding the flow label, yes, it was already considered. It is part of the DETNET IP data plane, where we have included also the flow label in the flow identification possibilities. And regarding the second aspects, maybe just a very short comment, but I think it is definitely worth for a longer discussion on the compression. So the DETNET specific seed must be always the last seed in your segment list. Therefore, I think that compression might be not so interesting, but this is up to further discussion. And depending on how you define exactly the DETNET specific seed, I see also options in order to have some compression on them. So that is definitely a topic where I think we need some further discussion. So very good comments. Thank you.
Thank you.
Janu?
Thank you, Balazs, for the presentation. I have a quick question for the clarification. Currently, it seems that only the pre-auth function of DETNET is considered. Are you planning to include any data plane solution specific SID format? Because as in the previous meeting, Totolus suggests such a draft to specify the header format for the data plane solutions. I think the similar effort has to be done in this document as well. Are you planning to extend your draft into the inclusion of data plane solutions, a specific SID format? Thank you.
You mean by the data plane solution, the latency related information, how to include that?
Yeah, currently in this meeting, I and Xiaofu presented two different data solutions, right? And each data solution requires its own header fields. For example, for me, the finish time, such a field is required to be included in the header or in the SID. If you plan to include that kind of information in the SID, yeah, I would like to hear that. Thank you.
Yeah, I think that is also something for further discussion. The queuing related information is something depending on the information format, you might have challenges to include it in a seed. But of course, other header options are also available for that. So in this proposal, we have just focused on the service sublayer in order to support those functionalities. But if we extend this to the forwarding sublayer, I think that is also an interesting discussion to evolve further this solution or just discuss about the existing proposals, how to converge in them. Thank you.
Okay, thank you.
Speaking as a contributor, just a comment reflecting on Shasong's point that yes, it is of course good to evaluate the differences between the two drafts. Just to note for the record, maybe not everybody was paying attention, that to my recollection, multiple comments made multiple times against that draft, that it is not in line with the DETNET architecture. And the quoted sentence was the workaround. There was no true solution to bring it in line to the DETNET architecture. And in my understanding, the idea behind this new proposal is to have something truly according to the DETNET architecture.
Yeah, I think it would be good to distinguish how this differs from that earlier work, because it seems like, at first glance, it seems like there's overlap. So if there isn't, this document should call that out. It also should justify why it is, what value it's bringing, and why we need a second solution, if at all. Shusong, you get the last word on this.
Yes, I think maybe we can reconsider the relationship of these two documents and whether we can seek some specific problem that could be reserved only in this document in line with DETNET architecture. I think we can have more discussions offline.
Okay.
And on the list.
Go ahead, Balazs.
Yeah, discussion offline and on the list.
Sure. Thank you all for I think, a very good session. I appreciate all the good contributions and discussion. We will see you on Thursday.
Thank you.
Thank you. You're going to come to the open source routing lunch?
No, I have a lunch meeting. There is a colleague here who is only here for today.